A very good morning to all of you. Welcome to ANB Exam Forum. In today's session, we are going to see units and measurement in physics. And this particular topic is very important for all the exam, including SSC, ISRO, CHSL, CGL, and many more other exam. Okay. So in today's session, we are going to cover 20 MCQ related to this particular topic. And all those questions which we are covering have come in either of these exams. Okay, so without wasting any time, let's begin the session. So the very first question is on your screen. The question says the smallest unit of length is what? Okay, so you have these four options and you need to tell the smallest unit of length. Okay, so student, let's see one by one. So the first one is micron. You should remember that micro is basically 10 power minus 6. Okay, if you see nanometer, nanometer is 10 power minus 9 meter. Okay, angstrom is basically 0.1 nanometer, or you can say 10 power minus 10 meter. Okay, and finally fermimeter, it is basically 10 power minus 15 meter. Okay, so if you see all these options, option D, fermimeter, fermimeter is the smallest of all. 10 power minus 15 is smallest of all these other unit. Okay, so those who have given option D, they are right. And all such pointers we have covered in our theory classes, where we have talked about the various units of length. As you know, the SI unit of length is meter, but there are some other non-SI units which are generally used in many fields. For example, for very small distances, these units are commonly used in the science. Okay, and most important one is the Fermi. Why it is important? Because this fermimeter is used to measure the nuclear radius. Okay, because it is very small, 10 power minus 15. And if you talk about nanometer, which is basically used to measure the atomic radius, it is 10 power minus 9. Okay, and as you can see, all these pointers we have seen in our theory classes. Okay, let's see the next question. A parsec, a unit of distance, is used to measure the distance related to star in the sky, is equal to what? Okay, again, you should know that parsec is another unit of distance, but this is astronomical unit, basically, which is used to measure the distance which are very huge. Okay, for example, if you want to know the distance to the star in the sky, kilometer will not be sufficient, because it will be in power of 15, 16. So normally some other unit are used, for example, parsec, light year, astronomical unit. Okay, but in this question he is asking about the relationship between parsec and light year. And remember student, 1 parsec is equal to 3.26 or 25 light year. Okay, light year is again one other unit of distance. This is commonly asked in the exam. Okay, so this 3.26, those who have given, they are right. So 1 parsec is equal to 3.26 light year. And all these pointers we have seen in our theory classes, where we have talked about the unit of length or distance which are used in astronomy. These are the 3 commonly units which are asked in the exam. First one is astronomical unit, basically, which is used to measure the planetary distance. And astronomical unit is basically, we have seen that it is the average distance between Earth and Sun. Okay, the next one is light year, and it is very important. I am marking it as very important because light year is a distance traveled by light in vacuum in 1 year. Okay, as a word, it is sounding, it is unit of time, but it is unit of distance. Okay, so it is basically distance traveled by light in vacuum in 1 year. Okay, and if you see, one light year is equal to 1.496 into 10 power minus 10 power 12 kilometer. Okay, so you can see how long this distance is. Okay, and it is used to measure the nearby star and galaxy. Okay, the next other important unit is the parsec, which is commonly seen as the largest unit of astronomy, and this answer we have already seen that one parsec is 3.26 light year. Okay, so all these pointers we have covered in the theory chapter. You can take a screenshot of this slide. Let's see the next question. Which one of the following is the reason why astronomical distance is measured in light year? A very simple one. So we have seen light year is one of the unit of the distance, and it is very popular in the measuring astronomical distances. Okay, so light year, first you should know that it is a unit of distance. I am repeating, it is a unit of distance, not time. So why it is being used? Because light year as a word itself suggests that the distance traveled by light in an year. Okay, so why light year is used? Because the speed of light is always same in the vacuum. Okay, so whether you are here or in some other planet or anywhere in the galaxy, the speed of light will remain the same. Okay, that's why it is one of the accurate measurement of the distance for astronomical. Okay, so those who have given option D, they are right. The next question, it is from the measurement, and I am marking it as very important. Okay, so how can the height of a person who is 6 feet tall be expressed in nanometer? Okay, so this is basically the measurement concept. So you should know the conversion. Okay, so let me write 6 feet is what? You should know how many meter or centimeter or any other unit, you know. So 1 feet, usually we know that it is 12 inches and 12 inches. Okay, and we know that 1 inch has how many centimeter? 2.54 centimeter. Okay, and if you multiply all these numbers, you will get 183 centimeter. But the question says that he is asking in nanometer. Okay, so nanometer, as you know, nanometer is what? 10 power minus 9. Okay, so in order to make it in nanometer, so what we will do, 183 centi means what? 10 power minus 2 and into nanometer. I am making it plus because I am making here as a nanometer. Okay, since unit is converted to nanometer, so I am multiplying with 10 power 9, not minus 9. Okay, so if you convert it, it will become 183 into 10 power 7 nanometer. Okay, so option C, those who have given, they are right. Okay, and we have seen the conversion related things like whatever these units that we talked just now are basically the imperial unit, which is commonly used in the older days like in UK or US. So the very popular one is the inch. Inch is 1 inch is 2.54 centimeter. This you need to remember. And 1 foot is 12 inch or 0.3048 meter. Okay, 1 foot is 12 inch. Then is 1 yard. 1 yard is basically 3 foot. Okay, and 1 mile, you should also remember it is 1760 yard or 15280 feet. Okay, but the most important one are these three one. Okay, at least you should remember these 3 units. Okay, and there are some other prefix which are commonly used in the units, like from deci, centi, milli, nano and all such things you already know, I guess. Okay, so these are also commonly prefix which are used in the units. Okay, let's see the next question. Which one of the following is not correctly matched? Okay, let's see. So unit is given and one the name of the unit is also given, so you need to correlate them. Okay, So first one is decibel. Yes, we know that decibel is a unit of sound, so this is correct. Horsepower, it is unit of power. Yes, horsepower is a unit of power. The other unit include watt. Okay. Nautical mile, yes, it is again the unit of naval distance. It is correct. So nautical mile is the unit of naval distance. So you are left with Celsius. Don't confuse Celsius. It is not unit of heat. It is a unit of temperature. Okay. It is a unit of temperature. Okay. Celsius is not unit of heat. It is unit of temperature. So this is not correctly matched. So option D is the right answer. Let's see the next question. Which one of the following pair is not correctly matched? Quantity and SI unit. Okay. So let's see one by one. Again, you need to very cautious. He is asking not correctly match. The power of lens, it is diopter. Very good. This is correct. Pressure, Pascal. Yes, Pascal is the SI unit of pressure. It is also right. Activity of radioactive substance, Curie. Yeah, this is a very blind spot. Okay, Curie is not the activity of radioactive of the substance. The SI unit is becquerel. Okay, BQ. Becquerel is the unit of radioactivity substance activity. And the unit of heat is joule. It is also right. So this is incorrect. So those who have given option C, they are right. And all such unit you should remember. So we have already seen in our theory classes that there are basically 22 SI unit with the spatial name. And if you see, the very important one which we are referring is activity referred to the radioactivity. It is becquerel. SI unit is becquerel. It is BQ. Okay. So other units are also there. I'm not covering everything on today's session. So you can take a screenshot or just remember all the 22 SI unit which is having spatial names. Okay. The next question, a very simple one. The unit of power is what? Okay, the unit of power. Let's see one by one. So hertz. Hertz is unit of what? It is the frequency. Okay, frequency. Hertz is a unit of frequency. Volts is a unit of basically potential difference. Watt? Yes, watt is a unit of power. And what about neutron? Neutron is one of the atomic particles. So this you can ignore. So, okay, so the unit of power is watt. Let's see the next question. How many watt are there in horsepower? This is very important question. Okay, so as we have seen, power is a unit of watt is a unit of power. The other unit is horsepower. Horsepower is again a unit of power. But you should remember the different relation between these two. 1 horsepower is equal to 746 watt. Just remember the relation. This is very important. So 1 horsepower is equal to 746 watt. And we have seen in our theory classes that horsepower is basically the historical unit which is used to compare the engines with the horses. That's why the name has come horsepower. Okay, basically horsepower tell us that how fast work is done, and just you can relate with the horsepower that the power needed to lift 75 kg to the height of 1 meter in 1 second. Okay, so just a simple theory about horsepower. Okay, let's see the next question. What is measured in cubic? Okay, so we have seen this terminology in our daily life, that this much water, this much cubic of water is released from the dam. What does this cubic mean? First you should know, and what it measures. Okay, so the first full form, if you know, you can easily answer this question. So cubic is basically cubic foot per second. Okay, cubic foot per second. And as you know, whenever there is per second in the quantity, it is something related to rate. Okay, and if you see all these three options, flow is basically the rate of water, how it is flowing. So it is flowing cubic foot per second, so it is the unit of flow of water. Okay, and the other few pointer, if you want to see, just have a look, that Q6 stand for cubic foot per second, and basically it is the volume of water in feet cube per second, and basically 1 cubic is 28.3 liter per second. And as I told you, it is used to measure the water supplied from the dam. It is not from, it is from the dam, canal flow and the river discharge. Okay, let's see the next question. A barrel of oil is equal to which of the following? Again, this is a very typical question. Why it is typical? Because this terminology we commonly see in news, like this much barrel is taken, or this much barrel of oil is imported to the country. Okay, basically you have seen the drum like these. Okay, these are nothing, these are known as barrel, and the capacity of those barrel is basically 159 liter. Okay, so this barrel carry 159 liter of the quantity. Okay, commonly it is used in the oil industry. Okay, so one barrel is 159 liter. Okay, and the other unit of volume, as you know, 1 liter is 10 power minus 3 cubic meter. Okay, that is meter cube, and one barrel is 159 liter used in oil industry. The other unit is 1 gallon, which is equal to 3.7 liter. Okay, this is again a good point. Let's see the next question. Again, I am marking this as an important question. The thickness of ozone in column of air from the ground to the top of atmosphere is measured in term of which? Okay, so basically if you want to know the ozone layer concentration, like we have seen in news that this much ozone is depleted. Okay, so the common unit which is basically used to measure the thickness of ozone layer is the Dobson unit. Okay, the Dobson unit is basically used to define the thickness of ozone layer concentration in the atmosphere. Okay, just remember this name, don't go with the ozone unit. Okay, so Dobson unit is the right answer. Let's see the next question. Which one of the following quantity does not have unit? Okay, you have to tell which of the quantity is basically dimensionless. Okay, so let's see one by one. Okay, so stress and force, let's see, force have the unit. Yes, force unit is Newton. Okay, the stress is what? It is basically the pressure. Okay, so it is force per unit area, that is force per unit area is meter square. Okay, force is Newton, so Newton per meter square. Okay, strain is the quantity which is basically dimensionless. Why? Because it is basically telling you the ratio with which the size of an object is changed. Okay, so this strain is basically a ratio, it is a constant. So this quantity does not have any unit. Okay, so option C is the right. And strain, you should remember that it is basically the deformation or change in shape of the body when force is applied. Okay, so suppose if force is applied in an object, so there will be change in length if force is applied. So the ratio, like how much it is changed with respect to the original length, is basically the strain. Okay, and remember, strain has no unit because this is in meter, this is in meter, so it will be cancelled out. So strain has no unit. Okay, let's see the next question. Which one of the following units of the pressure? Okay, so let's see one by one. Bar, yes, bar is a unit of pressure. PA is Pascal. Pascal is again a unit of pressure. Torr is again a unit of pressure, and D atmospheric, yes, it is also the unit of pressure. So option D, all A, B, C, D are correct. All are unit of pressure. And the other very important thing you should know about that, pressure is force acting per unit area. So pressure is force per unit area, and the SI unit is Pascal. You have to remember the SI unit. SI unit is Pascal. So 1 Pascal is basically 1 Newton per meter square. Okay. And the next one is ATM. ATM is atmospheric pressure, and this is very important. These two are very important. That 1 atmospheric is equal to 760 mm of mercury. Okay. This is mercury pressure, mm of Hg. So if mercury column is having pressure of 760, it is basically 1 atmosphere. Okay. And if you talk about in Pascal, it is 101,325 Pascal, or you can say 10 power 5 Pascal. Okay. Or 1 bar. Similarly, torr is similar to mmHg. So these are basically the two units which are same at least. Okay. Next is PSI. PSI is pound square per inch. Okay. So it is used in America. So pound per square inch. Square inch is the area, whereas pound is a unit of force. So PSI is again unit of pressure. So 1 PSI is almost 7,000 Pascal. And the very important one is bar. So bar is commonly used in engineering field, where 1 bar is 10 power 5 Pascal. This is very important. Okay, so 1 bar is 10 power 5 Pascals. Yeah, this is the question from measurement. 1 kgf per centimeter square pressure is equivalent to what? Okay, so let's see. So 1 kg force per centimeter square. Okay, so you need to find it in the term of bar. Okay, so first we will make it into SI unit. So let's convert into SI unit. So 1 kg force means, in order to convert into Newton, we need to convert in kgf to the Newton force. Okay, so it will become 1 into 9.8. Okay, for simplicity we will take 10. Okay, so 1 into 10 Newton. Okay, centimeter square we need to convert into meter. So as you know, centi means 10 minus 2. Okay, meter square. Okay, so what it become? 1 into 10. This is 10 power minus 2. It will become 10 power minus 4. Since it is denominator, it will come at the top. So it is 10 power 4 Newton per meter square. So it will become 10 power 5 Newton per meter square, which is basically 10 power 5 Pascal. Basically 10 power 5 Pascal. And you just now have seen that 10 power 5 Pascal is basically 1 bar. Okay, so option B is the right answer. Okay, so 1 bar is basically equal to 10 power 5 Pascal. Let's see the next question. Frequency is measured in what? Okay, so frequency is measured in hertz. Just now we have seen hertz is, you know, it is the inverse of time period. Okay, so frequency is measured in hertz. Okay, so option A is the right answer. 1 micron represent the length of what? Okay, so in the very first question we have seen this micron, and 1 micron is basically what? 10 power minus 6 meter. Don't confuse here, unit are in centimeters. So you should not answer 10 power minus 6. Okay, it is not 10 power minus 6 centimeter. Okay, it is basically 10 power minus 6 meter. So let's convert into centimeters. So 10 power minus 4 centimeter. Okay, so option B is the right answer. Okay, so 1 micron represent the length of 10 power minus 4 centimeter. Let's see the next question. Match the following. Let's see, it's very simple one. So high speed, whenever you have speed has a unit Mach. Okay, so this is match with the first option. Wavelength is basically unit of length, and out of this you should know that it is the angstrom is used to measure the wavelength. Okay, the next one is pressure. In few of the question that we have seen, the SI unit of pressure is Pascal, so Pascal is the right answer for this. And energy is joule. Okay, so there are 1 to 1, so 1 2 3 4, so 1 2 3 4, option C is the right answer. Let's see the next question. Which one of the following is not correctly matched? Let's see one by one. Not is basically the unit for the measurement of speed of distance. Yes. Nautical mile, unit of distance used in the navigation. Yes. Angstrom is unit of wavelength of light. Yes, it is also correct. Light year, unit of measuring time. No, it is unit of measuring distance. Just now in few of the question we have seen this terminology. So light year is basically unit of distance, not time. So this is incorrectly matched. So option D is the right answer.